So we're starting Unit 1.3, which is bivariate data and scatterplots. So really quickly, let's talk about what bivariate data is. Bivariate data is two pieces of data and how they relate to each other. So we're looking for a relationship, an association. We call it a correlation or an association because we're looking, how do these two things relate to each other? So for example, okay, so say I have this highlighter, okay? As my highlighter runs out of ink, so as I have less ink in my highlighter, I have less brightness in my color. So the how bright my pen draws and how much ink I have in the pen are related to each other. So there's a relationship there. There may be things that don't have a relationship. We'll talk about those too. But for now, we're looking at two variables, how and if they relate to each other, and how changing one changes the other. Okay, so we primarily look at that with scatter plots. There's other ways we look at that data, but we're going to kind of focus on scatter plots for today. So we have four different types of relationships or associations that we're going to be looking at. We have linear positive, linear negative, no correlation, or nonlinear. Okay, linear positive and negative are kind of most of what we're going to be working with in this unit. We're going to be identifying no correlation and nonlinear. And when we get to Unit 3 and Unit 6, we'll talk about quadratics in Unit 3, and we'll talk about exponential scatter plots in Unit 6. So let's start with the easiest, let's start with the easiest two, which are linear negative and linear positive. So let's start with linear positive. So first of all, when I look at linear positive, what I do to figure out what kind of association I have is, I take my badge, let's turn that over, we don't all need to know my name, I guess we kind of already do, but whatever. I take my badge and I kind of try to make, just in general, I try to make my badge kind of parallel to the data. So I want it to kind of look like it's running next to it. And then I slide my badge up into the data, and then I draw a line through it. Now, I recognize you're going to be taking your test on a computer, but you could literally hold your badge up. Don't write on your computers, please. But you could hold your badge up and slide it into the data to see that same correlation. You could do it on the screen. Okay? So, as you see, again, this data does not make a line. And as I said very, very humongously on the front, we never connect the dots on a scatter plot. But you can see that this data, in general, it looks like a straight line, and it looks like a straight line with positive slope. Okay? So, what does this mean? So the first thing we see is a graph with a line with positive slope. If we look at the table of values, do you see how these x's are increasing? So I have my x's are increasing in value. Well, what are my y's doing? They're also increasing in value. Okay. Now, if I took these and instead of sorting them greatest to least, I sorted them least to greatest, these would both be decreasing together. So the first thing that we see is our x and y, they change together. Okay, so that means if they're both going up, if one's increasing, the other one's increasing. If one's decreasing, the other one is also decreasing. So let's look at this. It says the number of hours worked and the amount earned. Well, if I'm working less hours, I'm going to make less money. That's a positive correlation because they're moving together. So what makes it positive is not that both of the values are increasing, it's that they're moving in the same direction. Okay? Likewise, the hours walked. So if I walk more hours, I'm going to burn more calories. They're moving in the same direction. So what we could see, some of the statements that we could see, like, because they'll give us a statement. So we might see as x increases, y increases. We might see as x decreases, y decreases. So what we're going to see is we're going to see them moving in the same direction when it's a positive correlation. So like the best way I can say is same direction. Okay, that's my positive correlation. Now my linear negative correlation, likewise, again, if I try to like put because I'm looking for linear, if I can see kind of in general, like there's some dots that are kind of out there, but in general it looks like this stuff's going downhill, right? So if I slide my badge in so I've got about the same number of points above my line as below, I get a line that looks kind of like that. And it's in general, the data in general is shaped like a line with negative slope. Okay? So let's look at what's happening with our x and y values. So in this case, I don't have them sorted greatest to least. I have them sorted I don't have them least to greatest. I have them greatest to least. Well, so my x values are getting smaller. Well, what's happening to my y values? They're getting bigger. So they're not going in the same direction anymore. They're going in different directions. So let's look at the situation here. It says the population of foxes and the population of bunnies. Well, when there's more foxes, what do foxes do? They eat the bunnies. So there are less bunnies. So more foxes, let me try a different color so you can actually see that. More foxes, less bunnies. Okay? If we have more, smallpox was like an old-timey disease. But as we had more smallpox vaccine, you can think about this with our COVID vaccine, okay? As we had more smallpox vaccine, we had less smallpox deaths. So you see they're moving in different directions. Likewise, if I had less smallpox vaccine, we would have had more smallpox deaths. So in this case, X and Y move opposite. That's the best way I could think of to say it. As X increases, Y decreases. As X decreases, Y increases. Okay, so let's write that down. As X increases, Y decreases. As X decreases, Y increases. So again, this time they're going opposite directions. Okay, so they're going in opposite directions. All right, so that's positive and negative, and those are the ones. Those linear positive and linear negatives are the ones that give us useful information at this point. Now we have our no correlation, and the best way I can think of to describe that is dots everywhere. Dots everywhere. And there's no pattern. Like what? There's nothing linear. It doesn't go uphill. It doesn't go downhill. It doesn't make a pattern. There's just no pattern. Okay? And so what you would most often see is, so like right here we would say no pattern. And then we would describe, like the statement you might see is, there is no relationship between X and Y. And when you look at a table, again, all of this depends on your X's being sorted. So if these are sorted in least to greatest, well, it goes up, then down, then up, then up, then down, then up. Like it's going all over the place. There's no pattern here. So as these increase, these just kind of go wherever they want to. So here's an example. The number of pasta dishes eaten and the number of cars on Highway 290. Like if you go, huh? That doesn't make any sense. If it doesn't make sense, it's probably got no correlation. Okay? So that's our no correlation. Our last one is nonlinear. So as you can see with this, like it doesn't make a line, right? But I can see this general pattern. So I can see a shape. So there's a relationship between these two variables. There's something happening, but it's not a straight line. And straight lines are all we're worried about right now. So like I said, we're going to learn about quadratic and exponential later in the year. Okay, so the last thing I want to talk about is correlation or causation. Okay, sorry about that. Okay, so the last thing we're going to look at is correlation or causation. Okay, so correlation means that they are related. Okay, so these two things are related. Okay, so that just means, yes, there's some kind of relationship between these two things. Okay, now causation means one of these things caused the other. Okay, so that says caused. Okay, so I'm going to rewrite it. Okay, one of these things caused the other. So again, we're looking kind of at a very fine point, like between whether two things are related or whether one of them causes the other. So let's look at this example here. So this example says, you can see, like if I look, I can see there is some kind of linear relationship here between these two variables. And it looks like it's positive. It looks like we have a positive linear relationship between ice cream sales and sunglasses sold. So what this graph is saying is ice cream sales and sunglasses sold are related, and it looks like they're going up. So let's say we have ice cream sales up, and then we have sunglass sales going up. But are ice cream sales increasing because of sunglass sales? Are sunglass sales increasing because of ice cream sales? Or could there be something else related to that? Like, I don't know, we sell a lot of ice cream in the summer when it's hot, and we sell more sunglasses in the summer when it's bright. So there are lots of reasons why things could be related. Just because they're related, that doesn't mean that one of them is causing the other to happen. Okay? So the critical statement is, does it have to? Okay? So if ice cream sales, do sunglass sales have to increase? No. Okay? We're going to do that same thing here. Okay, so if I work more hours, does my paycheck have to go up? I mean, like legally? Yes. So as my hours increase, my paycheck has to increase? Yes, because like, I mean, I'm not doing work for free. So this would be causation, because it's causing the other one to happen. Now, as a child gets older and their shoes, as a child's age increases, do their shoe sizes have to increase? Or do their shoe sizes decrease? Does one cause the other? This one is actually, I mean, I actually could go either way on this one, because think about it. Like, first of all, I've had size 10.5 shoes since I was 11 years old. Since I was a wee child, I've had ginormous feet, okay? Likewise, my sister, her feet, she got to size like 7 and they stopped growing. I've had big feet since I was little. But in general, yeah, in general, I would say there's a trend there. But there may be other things that are related. So this one I think could go either way. All right, so this one could go either way, okay? And again, I wouldn't expect you to see something this ambiguous on your test. It's going to be pretty straightforward. One, do I have to, if I change one, does the other one have to change? What about this one? The number of cold days and the amount of hot chocolate sold. So when if it's colder, as it gets colder, do I sell more hot chocolate? Yes. But on a cold day, do I have to buy hot chocolate? No. So this is just a correlation. Okay? The number of miles driven. If I drive more miles, do I have to get more gas? Absolutely, yes. If it's a yes, it's a causation. Okay, and that's part of what makes some of these tricky. Like this one in particular, part of what makes this one tricky is that it could go either way, and it's really a matter of how you interpret it. Okay, so those are the first 3 things that we had to cover. Let me know if you have any questions.